All right. Hi, everyone. Thanks for joining in. As you may all know, this meeting is recorded and will be uploaded to YouTube. Please adhere to Kubernetes guidelines. So we've got three issues. I just added the first one just because it's relatively urgent. Scalability, quote unquote, bug that I think worth quickly discussing because of the code freeze that we will have in the next couple of weeks. So we might want to fix it before that. So the issue is that you can see my the other tab, right?
Yes, it's a little small, but maybe you can reduce the size of your window or that. Yeah.
So in the scalability tests, they're testing, I think, on some 5,000 nodes, but there are a lot of daemon sets that are being deployed in that test. And the thing that they noticed is that, like, for regular pods, they get scheduled quite fast. They can get like upwards of 300 pods per second, which is great. But for daemon set pods, they are getting like below 100 pods per second scheduling throughput. And the issue here is that it's most likely because if you can see here, so for a normal pod, we typically evaluate, we don't really need to evaluate all 5,000 pods nodes. We just try to find 500 eligible ones and try to score them. But for daemon set pods, because there's only one feasible node in the cluster, the journey of trying to find 500 is basically going to fail. And so we have to go through all these 5,000 nodes, and then eventually we will end up with one anyways. And so that is, like, compared to just like a normal pod, that would be a lot more expensive. It's not the scoring phase itself that is more expensive. It's the fact that we have to go through all these 5,000 nodes just so that we pick the one node that is eligible. Even though that, if the, assuming like a, in a ideal situation, the scheduler is aware that this is daemon set pod, and then it will just pick the node and move on, rather than actually trying to find it using node affinity. So to give you some background, the way that daemon sets work is that the daemon set controller creates the pod and injects an affinity to the specific node where the pod should be scheduled, like on node X or node Y, like that exact node where the daemon set pod should go. So the scheduler is not aware of the pod, that the pod is a daemon set pod. It's just basically applying node affinity rules on it. And that's the issue, basically. Do you have any questions?
Yeah, thanks for raising this issue. It's a very interesting symptom. So yeah, definitely, I think we should do some specific logic in the affinity filter, because if I remember correctly, the daemon set controller injects a very special field called .metadata.name, or sort of like that. And that is right now is exclusively used by the daemon set part. So I think one logic we can do is to handle this kind of affinity spec specially. And if possible, we can just use a triangle node selector or metadata selector to locate that node specifically. So that can reduce the time to 01.
Yeah, so this is exactly what we have proposed here. It's not special to daemon set pods. It's basically like in node affinity, you can do selection based on labels or on fields, right? So you have two types of node selection. If you look at the node selector spec. So it's not really anything special to daemon set, but it is really it should be reliable to basically say, if we find this affinity to the metadata name, we can assume that there's only one node with a metadata.name matching, right? Like that.
Yeah.
But we can't do that for labels, right? Like labels are more
exactly
like free text, but for metadata name, this is already enforced by the API.
Yeah, it's unique. Yeah, it's unique one mapping to the node. Yes.
Yeah. So this should be reliable, and we can apply that as a pre-filter in the node affinity plugin. The other one that we could potentially explore is adding the daemon set controller, setting the node nominated node name. Since we already optimized for that, I think we've done that past couple of.
I don't think that would work because that's in
Yeah,
the
remove
status.
it, right?
That's in the status.
Oh, is it?
Yeah, in the status, yes.
Okay. It's not only this; it's also because the scheduler will actually might remove it if it fails. I think to schedule the pod for some reason. Maybe it could fail to schedule the pod because of not enough resources, and then it will remove it. That's not going to impact the correctness.
Well,
it's just going
also, I think it might not do preemption, or if there's already a pod that is being preempted, it wouldn't try to preempt more pods. That would also be an effect of nominated node name.
I mean, when you said the nominated node name, it's basically taking into account when you schedule the next pod, right? Like if it is higher priority.
Yeah, but if it's set, we assume that preemption happened, so we don't try to preempt more. Does that make sense?
In the next cycle, you mean?
In the next cycle, yes. We try not to delete more pods until all the ones that are marked for deletion are deleted.
Sure, but then there is nothing, so.
Right, but there might be another pod that put preempted a pod, and then you're only preempting that one. You're gonna wait for that to finish before you start preempting more.
Right, like I guess in general, this is like a hacky situation that
yes,
it's not really the cleanest. The other issue here is that in general, this is like one specific case for daemon set pod, but in general, when there is a lot of pods that are getting scheduled, like we may not really need to always try to find 500 nodes or whatever, like at that scale. And so to make the schedule more efficient, I was suggesting here as well that we could adapt the number of nodes that we need to find for scoring based on the length of the queue, the pod queue length. So if we have a large queue, then, the scheduler figures out, I have a lot of work to do. Let me not try to be extremely optimal or try to find the best node possible. I will just try less, basically, so that I make progress and make sure, it goes through the queue faster. So I think this is an interesting optimization we should look at as well.
I guess configurable through the component config, right? How aggressive?
Yeah, so I can raise another concern, I think, from some other serverless users is that right now we evaluated the paths according to the percentage of paths to score the field, right? So, but internally, for the serverless users, they want to the bin packing in a very fixed manner. I mean, internally, we sort of do this kind of random path selection, right, in a round robin way or whatever other way. So if they want to do bin packing, they want every time they select the same like 500 nodes to to evaluate, right? They don't want to this time to evaluate node 1 to node 500, and next time from 500 the 1 to 1000. So yeah, this is
No, but that should be easy to solve. Like, I don't even think we need to continue from the previous round exactly. You can just select a random starting point in the set of nodes and start from there. The question here is how many nodes I should look for from that point on. Whether I should look for 500 or just maybe 10 is enough, since I have a ton of work to do. Does that answer your question, concern?
No, I don't mean it's very related with what you propose to evaluate the nodes according to the queue names or so. We just want to similar, not similar, just related concern from users that the behavior that we evaluate the nodes in a random way. So for now, it's by default. You cannot change that. It's totally random if you're running a large cluster, right?
Okay, let's comment on the issue. Please, if you have any questions about it or you have an opinion, comment on the issue. Or if you want, you can speak up now.
Do we have, like, is it open for implementation already? Because we haven't done this from any pre-filter plugin ever. So
it
needs,
yeah, it needs some work because we need to return the code.
Right. So I guess we can discuss that in the issue if we want to go this path.
Right. Yeah. Okay. We've got a couple more topics here. Just want to give enough time. Mike?
Yeah. So I just want to preface this descheduling framework doc here that I have saying that this is a really vague proposal right now. I'm really trying to gather some feedback and input on what people think about this, if this is a kind of some good goals for the project or not. And the basic summary is that I'm proposing that we really fundamentally refactor the descheduler repo as it is into more of a framework to let people build their own deschedulers, and something that's kind of similar to the scheduler framework, or really exactly similar to it from a concept standpoint. This idea of a descheduler framework has been kicked around for a while, and I think that now is kind of a good time to start organizing it a bit better because we have a lot of different proposals and bigger projects that I kind of tried to outline in this doc in ways that they relate to the idea of a scheduler framework. But just for some background, like the descheduler project over the past couple of years has really grown a lot just by measuring issues and pull requests and feature requests that come in. And it's really done that without any kind of roadmap. Like the roadmap itself has been effectively ad hoc just from what people are requesting. And that has worked so far as kind of a central component where people want to add features to it and we review them and merge them, and we haven't really had anything that gets rejected in that point. But it's starting to hit some scaling issues with the growth of the project, and we're starting to reach a point where not only do we not have enough bandwidth to really effectively review and merge new proposals and changes, but some of them are just not really feasible to happen without like conflicting with things that we have already built in as assumptions to the project. So our solution to that so far has been to add like new feature gate flags and settings into our API, and this is also causing a scaling issue where our API is growing and not reaching any kind of stable setting where people can start reliably really trusting this and using it as a stable project. So what I'm trying to do is gather feedback on organizing some of these ongoing tasks that we've had into how they could look for a framework similar to the scheduler framework. The goal here basically being to shift the feature development tasks really out of the hands of the maintainers of the descheduler project and put that, enable that, but also encourage that in third-party developers so that people that want really custom pod eviction logic, it can be idiomatic for them to build that themselves. And that frees up our maintainers to work on building a stable platform that other people can reliably build on. So that's basically the summary of what I'm talking about here. I really just want to get a lot of feedback from anyone that's interested in how this would work, what it would look like. I tried to put a couple of questions at the bottom of the document that I posted to get the conversation started and try to come up with like, what would a descheduler framework work like? How do the existing features fit into it? What kind of future work could we expect from it? And any other questions that people think are worth addressing. That's really what I'm looking for is input at this point. When we get enough input, I'm imagining that this will take a little while to sort out and organize. I would like to start on some sort of work for this, some concrete work in the next release, like the Kubernetes 125 timeline, if we decide to go ahead with this kind of approach. But as part of this discussion, I'm also open to any completely alternative ideas. My main summary, a goal here is just to kind of alleviate some of the pain points that we've had and really steer the descheduler project towards a more stable platform for these kind of eviction controllers. So open to feedback, just putting this out there right now. And we have an issue on the GitHub repo. I'm sure that there's probably people on this call that have had pull requests to the deschedule that have sat for a long time or hit a lot of review or gotten blocked because of conflicts with everything. So my desire here is to alleviate that and get a better workflow for the project. So if anyone has the time and you're interested, please leave some feedback, answer some of the questions that we have in here, work on this proposal. I want this to be a collaborative proposal through the people that are invested in it. So yeah, that's basically it. I don't want to really discuss any of these questions right now. I want to let people have some time to think about them and work on them offline. And maybe in the next SIG meeting, or if this is a big enough task, maybe this becomes its own regular meeting that we would have to have among the people working on it. I don't know. That's what I'm looking for from people. So that's it in a nutshell. If you have the time, please take a look at this and feel free to help out. We're looking for people that can contribute.
Thank you. Any questions? Quick ones?
Is the objective primarily to be able to review better and have some separation of concerns within the code, or is it also about like starting a new descheduler plugins repository that is separate from the descheduler?
Yeah,
where does it end?
I think that that's one of the open questions that I would really like to get some feedback from people on. I don't want to bias the discussion too much, but my thinking is just to kind of alleviate the reviews, like you were saying, like your first point there, like make reviews easier for the descheduler and give our maintainers the time to work on building a more stable component that can, eventually graduate to a V1 API. It could follow the same pattern as the scheduler plugins, where we have a more open process for people to contribute, strategies and stuff there. But that's part of the design that we'll have to figure out and see if people are interested in.
I think another question worth exploring is whether you want to do the same way that the scheduling framework and scheduling plugin are wired. So right now we have to recompile the whole binary, right? And in terms of this scheduler, I'm not sure because it's not quite a. If you look at if you don't look at that as a central component, maybe you can leverage some other interaction mechanism like gRPC or some other things. So you don't need to recompile the whole binary. So that may be one option to explore.
Yeah, I think that's a good idea, and also part of what I'm looking for, because I think since the scheduler framework has really been pretty successful to this point, but I'm hoping that there's maybe some things that we could learn from that to apply to this. Points like that where making it so you don't have to recompile a new descheduler would be useful.
Is there any thoughts on adding descheduling to the inbuilt scheduler, so that after scheduling, if certain constraints are no longer being maintained, there's some kind of descheduling that can happen in the inbuilt scheduler itself?
That's been asked a lot, and people have requested that a lot, but there isn't any plan for that right now that I can tell. It's
so any reasons for why it has been asked for a lot but not being prioritized, as in like?
Because in general, like we want to have separation of concerns. So the scheduler is not necessarily like, it's a pod to node placer. We do have preemption, but that's mostly to place another pod, not necessarily to rearrange the placement of pods. It's similar questions about autoscaling as well. Like the autoscaler is also a separate controller, not as you would have expected, like in similar systems where scheduler, descheduler, and autoscaler, all of them are a single, binary, let's say. So this model, like in general in Kubernetes, where each controller is concerned with one task, has been relatively scalable, maintainable, and working well. So the question here is, descheduler not successful by running on its own? Why do we want to merge it with the scheduler if this descheduler on its own is making reasonable decisions?
Yeah, I think it's a good point. I mean, yeah, I agree. I think it's essentially more of a scheduling decision from a scheduler point of view versus rearranging pods. I think my goal would be to like, I don't know if descheduler is the right. The main issue I see is probably the fact that you need to write two different configurations for scheduling and descheduling, and maybe there is a scope for one single spec that can basically do both schedule time and runtime configuration. Maybe that's something we could do. What do you think about that?
I don't want to take up too much time with the descheduler, because I think that there was one more thing
Sure.
on the schedule, but just to wrap that part up, I think that this could potentially relate to the framework idea, because if it's, if this is an easy enough importable framework, maybe we do revisit that. But I think that the idea of merging the descheduler into scheduler as a whole is its own pretty big topic that I don't want to take up too much time discussing, and we could definitely open another issue offline to start the discussion about that.
Thank you, Mike. I'm happy to stay for another 15 minutes, Asser, if you want to present.
Don't hear you anymore.
Sorry?
Sure. You were, sorry, maybe it was me. Sorry, I'm so sorry.
Right, so let me share the screen.
Are you able to, or do I have to make you co-host?
Yeah, I'm not able to share.
Or I just made you a co-host. Should try again. Maybe I should stop sharing. Make co-host.
Right, so I'll try to be quick. Can you see the screen?
Not yet.
Nope.
You cannot.
No.
Nope.
How about this one?
No.
No?
Do you want me to share it for you? Like, is it the
Yeah, the presentation.
presentation? All right.
Right, so I'm not sure. Hello, everyone. I'm not sure how much time I have, but I'll try to be quick. This is a proposal for a scheduler plugin that deals with overcommitment. So Chen is also on the call, can chip in anytime. I believe you have to go in a couple of minutes. In any case, why do we need to look at overcommitment? As we all know, schedulers just place pods based on what they request, and that's the guaranteed by the Kubernetes scheduler. You guarantee that you're going to get your requested and not your limits. Limit is a nicety that a container could use and could grow into and spike load into it. But there's no guarantee from the scheduler that you're going to get that much resources, which makes a lot of sense. The problem is if the scheduler is not aware of these overcommitment and not aware of the limits of these pods, then they could get scheduled on one node, for example, then they compete with each other, leading to performance degradation because of CPU throttling. You could even have OOM kind of things if the resource is memory. So this particular plugin is proposed to look at, in addition to requests, look at limits and consider those, not guarantee them, but consider the limits so that you place the pods basically on nodes, the pods that are burstable and best effort. On nodes where they can grow, they can grow their usage beyond the requested up to the limit, and at the same time make sure that when they grow into that room, they don't compete with others. So we look at both the values of the limits as well as the actual usage, the actual load on those nodes. So let's move on to the next one. Right, so as I said, burstable and best effort, that's what this plugin is targeting. The guaranteed one, they don't, there's nothing else you can do with them because this is about limits, right? So they are basically these containers that are burstable and best effort. They are telling us that they're gonna grow more than what they requested, may grow into it. So it would be nice if the scheduler can consider that and give them, again, room to grow, and that room should not be congested. So that's basically the idea. It's a very simple idea. If we move on to the next one, what this plugin is going to basically evaluate two risk factors, and these two risk factors will make up a risk value that would evaluate into a score. So as such is a score plugin. It will do a scoring of the nodes based on the risk, and the risk has two factors, what I call a limit risk and the load risk. The limit risk is based on the values of the requests and limits of all the pods in the cluster, as well as the pod that is to be scheduled. And the load risk has to do with actual load measurements. And luckily, we already have in Trimaran plugins, there are two plugins there that use a load watcher, and the load watcher is providing through Prometheus and other providers data about the actual load on those nodes. So we're going to take that and evaluate the risk of how much load there is and what's the chance that if we place a pod on that node and it goes beyond its requested, it's going to have a lot of competition or congestion. So the next slide, please. And the suggestion is to add this plugin as a third plugin to the Trimaran family because they all use the same load watcher that provides load. So as such, this is a load-aware plugin, and as well as limit. How does it differ from the other two? At a very high level, so the trimaran, all of them are load aware, so they do something with the load. The first one looks at the average and basically considers all pods. The second one looks at also not only the average, but the variation in the load. And the proposed one, trimaran 3, would also look at the limits in addition to the load. And as far as load, it looks more than just the average and the variation. It has to compute the tail of a distribution, which is the probability that if you place a node on if you place a pod on a particular node, it will compete with others with this probability or chance. Okay, next one, please. Right, so I show here two use cases, one that talks about the limit risk, the other talks about the load risk. So as far as limit is concerned, let's imagine that you have two nodes in this picture here. Node 1 on the left has two pods, A and B, and node 2 on the right has two pods, D and E, and they have these requests and limit. Both of them have the same, both nodes have the same request values, so a default scheduler would pick whichever to place the new pod X. Now, if you consider limit, you can see that node 1, if you add up the limits of A and B pods there, they go beyond allocatable, beyond capacity, whereas in node 2, they don't. So it's better probably based on that to place the new pod X on node 2. This way it will have most likely chance to grow its usage beyond the requested 1 up to its limit of 3 without any guarantee. Okay, so that's at a high level, that's what the limit risk is all about. Next slide, please. How it's computed, the risk itself, this is very simple formula that says, okay, I'm gonna add up the allocated on which are the requests on the node, and I'm gonna add up all the limits of all pods on the node. I will evaluate something that's called the excess, which is the between allocated and total limit, including the pod to be scheduled, and the allowed, which is the available room on the node. And I do this for all resources. So if it's CPU memory, let's say, so I'll do this for CPU, I'll do this for memory. And then this risk limit is nothing other than a value between 0 and 1 that says if the risk is 0, then there's no risk. And that would happen if, for example, excess is the same as allowed. Then there's no risk of going beyond what you want. You're going to get what you want if you want to. And the risk of 1 when you really don't have room at all to grow. So that's the formula to compute the limit risk. That's the first factor. Secondly, next slide, so it shows the second, the use case 2, which is how about the load, the actual load. So here is the same arrangement again of node 1 and node 2, but because in node 1 you look at that distribution there of load, that there is some chance that the load is between 2 and 4. 4 is the capacity of this node, of both nodes. Whereas node 2, all of the load, and it's an extreme case, but all of the load is between 2 and 4. So if I place a new pod X on node 2, is going to really be competing with others more likely than node 1. So in this case, I will favor node 1 based on usage. Okay, so that's the idea. Move on to the next slide. And so how do we compute that? Well, the risk of competing with this load is we look at the distribution, we look at the probability that usage or load is beyond the allocated. And we compute that and we say that's the risk. And again, it's between 0 and 1. If all the load is below allocated, then there's no risk at all. If all the load is above allocated, then there is a lot of risk, and anywhere in between. Okay. So next slide, please. What do we do with these two risk factors? Well, very simply, we just do a weighted sum. We have risk limit and a risk load. We multiply by some weight. Default is a half that they are equally likely to contribute to the total risk. That's a configurable thing. And so the total risk for that resource on that node is one value between 0 and 1. We consider all the resources, let's say the risk of the CPU, the risk of memory, the resource with the highest risk. We take that and we say the 1 minus that times 100 is going to be the score of that node. That's it. Next slide, please. Yeah, I don't have to go through another example. So that's basically the idea. Any questions?
Yeah, thanks, Esther, for raising this. I think it's a very practical challenge in the real cluster. So I have one question. I think you mentioned two factors to serve as the input of this kind of score plugin. So in terms of the first factor, you look at the limits. I think that quite depends on how correctly the users sets their limits. So what if they like just request as one CPU and then the limit sets a very large number, but they never reach that limits. So does that mean the first factor will totally useless? And then you have to totally look upon the second factor, that look at the real load of the node.
That's a good point. Yeah. So these two factors, the first one, as you noted, it's based on, it makes its decision based on what users specify as limits, and they could be wrong. And that's when the second factor is going to fix that by looking at the actual load. So on one hand, you could say, well, why do I need the first factor? On the other hand, well, what if the load is the one that is not right? I can't think of an example, but let's say that but judging only by the actual usage may not be enough to assess what the limit is. In other words, if a container once in a while goes above its requested, based on how much is going above its requested, I cannot say, okay, the limit is going to be the maximum of that or twice the maximum or something like that. Maybe making that as an estimate may not be accurate because you know, maybe that's what happened in the past, but in the future, all of a sudden we're going to see a big spike from that container.
Right. I think you. This is how I understood it. Like one factor is basically trying to take the future into account. The other is doing things based on the past.
Right. It's one is based on the past measurements, and the other one is based on
Potential of growth.
What's in the specs.
Yeah. Yeah, and the spec is basically saying, like, if you have high limit, it says that in the future you could grow into that limit.
Yeah.
And so I think it's reasonable to take it into account. Any other questions from the community?
I have one. A little bit about the how does this play with existing plugins? Is it expected that users could use the three of them at the same time, or should they choose one out of the three? Do you have any insight?
That's a good question. They don't have to use, of course, they don't have to use all three. I think that all Trimaran, I'm calling them, abbreviating them as Trimaran 1, 2, and 3. And in the table, I kind of contrasted them. So typically one would choose only one because you don't get any benefit from using the three. First of all, Trimaran 3 here doesn't do anything to the guaranteed pods. Guaranteed is you're going to get what you're asking for. So it doesn't. I believe unless there is an indirect effect, that it won't help or it won't hurt the guaranteed ones. So how about for burstable and best effort? What does trimaran 1 and 2 do is that they base their placement on actual load on nodes, whether average or average plus variation, but they don't look at limits at all. So if pods are concerned, if a user is concerned about work on those pods or containers within the pods that's going to grow beyond request, then definitely trimaran 3 would be the one to choose.
Yeah, I guess I wonder what's the best way to either converge, like, is it possible to have one plugin that you simply configure differently to behave differently instead of having 3 plugins? Just to simplify the user experience, because someone that is not very familiar has to choose, and maybe they decide, maybe they think using the 3 at the same time is the best, and it might not be. So if you just give them one with different configurations, and it might be easier to use.
Yeah, I see what you mean, and I think it's a good suggestion. My only feedback is the common thing about these 3 trimarans, right, is that they use a load watch. They use the data about metrics of usage of resources on the nodes. That's the common thing, but they have different objectives. Each one of them has a different objective. Only thing in common, and they belong to the same family, is the fact that they are load aware. I can imagine many more scheduler plugins are gonna be proposed, saying, "Oh, we want also to be load aware, but we have this other objective in mind."
Can clarify the documentation, and maybe that's enough. Yeah, that's my only feedback.
Yeah, that's something to think about.
Thank you, Eldo. Any other questions?
Yeah, no question, but suggestions that maybe the trimaran 3 can also apply to all pods, because the limits itself, well, it's not accurate, right? It depends on how the users benchmark their workloads and set the limits. So maybe you just take this guaranteed pods out, just apply this to all pods, but just a suggestion that we can evaluate.
Yeah.
Hey, my question is, like, how do you evaluate these, and what is your success criteria? How do you determine that you're actually making things better? How do you measure?
Right. So the experiment would be like, I would have a cluster with some pods that are running and going and beyond the requests, heavy load, maybe once in a while. And then I have this new pod that is also going to have a lot of demand. And I would schedule with the default scheduler and schedule with trimaran 3 and see how long, for example, how long it took to run based on one schedule and the other.
I mean, this is not like a scheduling latency or scheduling throughput improvement. This is an improvement on how much resources a scheduler is able to burst into. And so basically what you're saying is that you want to measure the performance of the workload, right? Like not the scheduler performance.
Yes, yes.
And did you do that? Like, did you?
Yeah.
Okay.
I think, yeah, go ahead.
I did, but on a synthetic kind of environment and not a real one. In other words, I had my own, generator of work, which is just using a stress kind of
Right.
tool, that kind of thing, but it's not a real kind of application.
Right, and this is like my follow-up question here is like, if we are to, suggest these plugins to customers, to users, what would we tell them? What type of workload, example workloads? Like, it's not enough to say, okay, I have this synthetic workload that basically maximizes the success of the plugin that I implemented, and you try to match into it. Like, you can always manufacture a workload that works well for the plugin. And so it would be really, really interesting if you can have a real workload that can show it actually did better. And it's not the workload itself, right? It's not just the application per se, it's also the mix of workloads that are running on the cluster that would contribute to whether this is actually going to be useful or not on the bigger scale of things.
Right.
Yeah.
Let me add to that. I agree with you 100%. Let me add to that. I've recently seen a scenario on, I believe it was on SIG scheduling somewhere, where someone was saying that pods, when they start for this kind of workload, when they start, the init container takes a lot of resources, and then after that, it's very normal, right? Yeah. So there's a lot of demand in the beginning, and if you have a bunch of these, all of a sudden, they are surging. There's a surge in demand in usage, right? So I was thinking maybe this would help in this case by just detecting that these pods have a limit that they grow into, so they're not going to be scheduled on the same node. So they're going to be basically scheduled on the kind of round robin. This is an extreme, right? And a kind of round robin on the nodes in the cluster. So that's why they get separated when they do their surges in the beginning, and after that they're okay. I don't know if I clarify.
Yeah, I know what you're talking about. That's an issue there. Yeah, I think, I totally agree with you and Abdullah that we do need a tool or simplified process to evaluate how this plugin works. Like for this kind of Chamber 3, I think the correct procedure is that in a normal default scheduler with the default config, that you load up the cluster with the specific request versus limits, and maybe put some CPU intensive workloads there, and you can notice some OM or out of CPU. And then with the Chamber 3, you can see this symptom can disappear in a very consistent way. So that can be a very good evaluation procedure that you prove this plugin helps a lot and will be super convincible to others. Yeah, but we are lacking of this kind of simulation tools on this, I think. Yeah, but internally, I'm building some kind of simulation to sort of fix the gap. But yeah, in some time, maybe I can share.
Yeah, so adding to that, I just commented in the chat that this is really valid for the Java workload, because for Java workload, we need a huge CPU and memory for the startup, and then everything will go down. So by having this example, this is really valid example, and we saw this. We are seeing this problem a lot by not overloading the node, but it's like, okay, I dedicated a very huge node for the Java workload, but after the startup time, I don't need it. I don't need this huge node. So this is really benefit for this scenario, and I believe we can use this example as a validation, or to make sure that yes, this plugin is really valuable now.
Thank you.
Thanks. Any other questions? All right, thank you, Asir. This is really interesting. I love the direction of this project, and the fact that there is attraction, and I was just trying to play devil's advocate, trying to poke into the methodology and see if there is a. But I'm really interested to see at some point that this is being deployed in an actual, like, real life cluster. And I'm wondering if this is something that you are planning to deploy on IBM. I don't know if IBM actually uses Kubernetes in some form.
We use Kubernetes quite a bit.
Okay.
I think next time, maybe you, as a Chen or Abdul from PayPal, can demonstrate this kind of trimaran from the end-to-end workflow, like how the metrics like, what's the metric provider you choose, and then to see with versus without this tracking, how the workflows looks like. That could be a super interesting demo.
Yeah, that would be great.
All right. Thank you all.
Thank you.
See you and
Thank you.
bye.
Bye.